It seems like impossible to an outsider. Like what got you motivated to keep going and to make this work?
I think that for me, the only problems that are working on are the ones that are going to have massive societal level implications.
오늘 소개해드릴 영상은 미국의 플라잉카를 만드는 조비라는 기업의 CEO 인터뷰인데요. 제가 요즘 이 기업에 푹 빠져 있답니다. 투자를 권유하는 영상은 절대 아닙니다. 팔란티어가 잘 될 수밖에 없는 기업이었다면 조비는 제발 잘 됐으면 하길 바라는 응원을 하게 되는 기업입니다. 이 기업의 스토리와 CEO의 마인드가 너무 멋있어서 영상을 한번 준비해봤습니다. 공교롭게도 진행자가 팔란티어의 창업 멤버 조론스데일인데요. 한번 감상해보시죠.
My friend Joben's been working on flying cars for about 20 years. This has been an idea that's coming for a long time. It seems like we're really close. They're working closely with the Trump administration, and the FAA is moving fast. Joben's now raised billions of dollars. He's scaling up manufacturing for groups like Toyota, preparing to launch in Dubai, preparing to launch in America very soon. Is this as big a deal as the automobile? Joby thinks it is. He thinks our lives are going to change dramatically in the next 2 years. Let's hear from him about Joby Aviation. Welcome to American Optimists. Excited to have with us here today Joby, who is CEO of Joby Aviation, a good name for a company. I was an early investor in Joby, and I'm really excited. You're making flying cars. You know, I think Peter Thiel had a catchphrase in 2011. I think he said we wanted flying cars. Instead, we got 140 characters. Did you ever think about that when you were building this company?
Absolutely. It was absolutely inspiring to think about being able to transform the way we move around. And first, I'd just love to say thank you so much for your support for so many years now, coming on a decade, and having partners like you on this journey has just been invaluable. I think when we look big picture at what we're trying to accomplish, we want to usher in the first transformation in the way people move around on a daily basis that we've had since the advent of the automobile, and the implications that has on life and the productivity of our societies, I think, is really exciting.
It's a really big jump. I actually tried to bring Peter and his guys in when I first got involved. Unfortunately, I don't think they got very involved, but it's definitely an inspiring idea. Since then, you've obviously raised, I think it's been a couple $1 billion. I think there was recent news on Toyota coming in again and backing you guys. So this is a big public company now. Tell us about the product. It carries 4 people plus a pilot. It has six rotors. What does it do?
Yeah, so it's an electric vertical takeoff and landing aircraft. So it can take off and land vertically, but then transitions and flies on a wing very efficiently. What this means is that we're able to build aircraft that has capabilities similar to a helicopter, but it's dramatically quieter. It has redundancy across all of the systems.
There's double redundancy, right? If you lose 2 rotors or any 2 batteries, you're fine, which is pretty. So the idea is to be extremely safe.
Exactly. In fact, we've got 2 aircraft down at Edwards Air Force Base, and with those aircraft, we've been able to demonstrate the incredible robustness, and we've intentionally shut off lots of different systems on the aircraft and demonstrated in flight that piloting the aircraft, there's no change in piloting the aircraft. So it's transparent to the pilot even after you've had failures. And so again, putting layer on layer of redundancy across all the different systems.
So let's go back a little bit in your life. I think at one point Larry Page tried to hire you. I remember hearing about this when he was trying to build like flying cars and stuff. Like, how long have you been thinking about and working on this area?
Yeah, so this has been a dream of mine since I was a kid. Worked on it when I was growing up, and I inherited my uncle's model airplane collection and all of the engines and stuff, and then convinced myself I needed to go get an engineering degree if I was going to make this dream come true.
Where'd you grow up?
I grew up just about 20 miles west of here on the Pacific Ocean amongst the redwoods, and it was an idyllic childhood. Incredible gardens and animals, and like for me, I couldn't ask to have had a better childhood, but it was also in the middle of nowhere. I was born off the grid before living off the grid was cool, and it was a long way home from school. So I loved where I went to school, but it was like 2 city bus rides and then a 5-mile walk. And
so this inspired you as a kid, being like, "This is too long. I gotta go faster.
I gotta get here faster."
It's very funny. So this is like you're creating a new commute. That's like, how fast are these first machines now?
So 200 miles an hour.
200 miles an hour. So you're thinking about this since you're a kid, obviously, and you love airplanes. Where'd you get your engineering degree?
So undergrad at Davis and then grad school at Stanford. When I was doing my undergrad, I had the opportunity to work on electric VTOL for the first time. So a company I was doing an internship with was building combustion VTOL, but they also were building electric VTOL for doing inspections. So like the first quadcopters, 1993.
Wow, so these are kind of early drones, basically.
Exactly.
Yeah.
And so I did a bunch of research on batteries and what the progression of battery chemistries was looking like. At that point in time, we were running NiCad and nickel metal hydride batteries.
So that's 32 years ago. How much lighter are they batteries for the same power storage these days?
So at that point in time, we were 40 to 50 watt hours a kilogram. Now we're more than 300 watt hours a kilogram. Wow. And there's cells in the lab that are up to 500 watt hours a kilogram, and prototypes coming that are over 1,000 watt hours a kilogram.
Well, so 40 to 50 to 300 today, already seeing 500 pretty soon, and 1,000. The current Joby machines we're testing, what are we using? What's density? Is that the 300?
Exactly.
Wow. So if you get to 1,000, it triples the range, basically.
Well, it's even more than that because you hold a lot of the energy in reserve for contingencies. You don't need to increase the amount of reserve that you hold.
Yep.
And so if you double the energy in the battery, you're actually probably getting 3 times the range.
Amazing. So right now the range is going to be like 200 or 150.
So it's we'll be launching on routes of up to 100 miles.
Got it. So because there's lots of contingency, you're really keeping it super safe. If something goes wrong, you just go pretty far to go somewhere else.
And then last summer we demonstrated a 500-mile flight with the hydrogen electric aircraft. Mm-hmm. And so there's incredible capabilities when you look at hybridizing, whether it's turbine electric or hydrogen electric, for taking the incredible safety that you get with battery electric or with electric propulsion, the acoustic signature you get with electric propulsion, and extending the range and capabilities.
So jumping back into the, because I was just so fascinated by the product, I love talking about it. So hydrogen, how much more energy dense is hydrogen than the batteries? Like what's the ratio there? How do you think about that?
Hydrogen is 100 times higher specific energy than today's batteries. It's 3 times higher specific energy than jet fuel. So if you care about building an aircraft that can fly long distances or can stay in the air for a long time, hydrogen is a total game changer.
And we all were like brainwashed from this 90-year ago Hindenburg disaster where the hydrogen blew up, and I think of hydrogen, I think of like, oh my God, I'm gonna explode. And so why is that the wrong reaction?
Well, so the interesting thing about the Hindenburg was actually the envelope. It was the fabric that covered it that burned. And the hydrogen is so light that it convects incredibly rapidly. Mm-hmm. So it's actually not.
It didn't actually explode, the hydrogen.
No, it was just the fabric burning.
I didn't realize. I always assumed the hydrogen somehow exploded. Oh wow, that's really crazy. I have a friend who, I shouldn't mention his name, he was like a prince in Germany, and I think his ancestor was part of like the people who funded this, because it was all the aristocrats in Germany, of course, at the time, who were creating this new thing, and it totally destroyed that mode of travel, which I think is too bad, because it could have been interesting if they got it right.
But there's phenomenal work going on. You look at Sergey's got a company close to here, Lighter Than Air Ventures, that's doing spectacular work on lighter than air aircraft,
which could be very fun. But why is Joby the answer to? So you're saying you want to change how everyone gets around. This is not just for like rich people to have fun. Like why is this thing scaled to everyone?
Yeah, so I think of where we are today as similar to where automotive was in the late 1890s, and where we were building tens and then hundreds of cars per year. And then as we drove that manufacturing scale, that allowed us to bring the price points down. So as we launch the service, we want this to be comparable in price to taking an Uber Black. Yep. And then as we drive that manufacturing scale and get to hundreds and then thousands and then tens of thousands of aircraft per year, and really leveraging the manufacturing muscle, then we want this to become as affordable as driving.
And you've taken on obviously a ton of really hard regulatory, really hard engineering challenges. One of the hard challenges here is just manufacturing at scale. I guess Toyota has announced recently like even more investment in you guys. Is that a big part of solving that and like learning how to scale this up? Absolutely.
Having the world's leading automotive company that's known around the world for incredible quality, incredible reliability, and a real attention to detail. Having them deeply integrated with us has been very, very valuable. And then as we look to this manufacturing ramp, they build roughly 10 million automobiles a year of the 100 million automobiles that the world builds every year. So 10 million cars. It's a very complex machine. It takes incredible supply chain prowess, and doing that with the consistency and reliability that we're looking for, having their expertise on manufacturing scale as we move from tens to hundreds to thousands and tens of thousands of aircraft a year, we think is incredibly valuable.
They have a bunch of plants in the U.S., right? They have a lot of people here, and then so are you doing another plant kind of with their help in the U.S., or what's the idea?
Absolutely. So we're an American company. We've designed, built, tested this aircraft here. We have our manufacturing here. We employ more than 2,000 people.
Wow, 2,000 already.
Yeah. Toyota has, more than 60,000 people here in the U.S., 14 plants. They, build everything from engines to transmissions to automotive components to the full cars. We couldn't dream of a better partner.
Don't tell us anything we're not supposed to know, but like how many, you said it's like the 1890s where they were building tens and then hundreds and then pretty soon even more cars. Like what's realistic for how many of these types of aircraft are created? I imagine if we're all going to be using them in cities and stuff, you're going to need tens of thousands. Like what's the ramp look like the next few years?
Well, we need to get to millions, but it's going to take time to get there, right? Yep. That's the reason why Toyota is such an incredible partner there. Today we have capacity to build about one a month, and we're ramping that as quick as possible. We've got doubling our footprint, manufacturing footprint in Marina, California. That plant's coming online this month.
Is this really the right place to scale it up?
Well, then we've got Ohio, and so we purchased a building there. We're starting to hire the team there and install the tools and
what could that be? Could that be 10 a month or something, or like how do you think about that?
Well, we need to scale again to hundreds of planes a year and then thousands of planes a year, but we do need to take it in a stepwise way.
Yeah, of course. And then so when can we first expect to be flying on these in public? You already had test flights with pilots. You've had a bunch of things working really well. Obviously safety is key, and you've done really well there. I hear rumors Dubai could be the first place. Is that what's the timing on that? Maybe end of the year, or what are you thinking?
Yeah, so we've shipped the first aircraft off to Dubai. We're going to have it there doing hot weather testing this summer. And
I guess it is really tough when it's hotter. Things don't have as much lift, huh?
You have to put more power into the propellers in order to generate the same amount of thrust. And so not only are you delivering more power, but it makes it harder to cool. So when it's
make sure it's not overheating. This is a problem in Texas too, by the way. We have better regulation there, but we have hotter summers.
So we've done amazing work. The team has done fantastic testing. We've tested it in the lab, tested it down at Edwards where it also gets hot, but now it's game time, and we're really excited to show what this aircraft is capable of.
Is there anything you have to do to like these propellers after they're running for hundreds of hours in the heat? Like what do you change to make sure they don't break?
So the propellers are incredibly robust. The team has put them through millions and millions of cycles where we're loading them at loads that are far higher than they'll ever experience in flight. So it's the certification process that we've gone through over the last 6 years with the FAA has been a very, very rigorous one. And it, again, is the foundation upon which the incredible safety that we've designed into this aircraft is built. Is
there anything you changed like 3, 4, 5, 6 years ago based on what you learned to like make it even more robust? Like what are the types of things you learn as you do these crazy tests over time?
Well, that's what we've incorporated in. So like we began flying transitioning full scale aircraft in 2017, and we've now gone through multiple iterations that have been about making the aircraft more reliable and ensuring that they meet every single one of the requirements that we've agreed to with the FAA. So we were the first company to complete the stage 1 of the certification basis, the first complete stage 2, first to complete stage 3, and now not only Joby but the FAA is making record progress on stage 4. 2 quarters ago we announced that the FAA was making record progress. This last quarter we announced that they made even more progress, and that progress is continuing to accelerate, where the lean in from Secretary Duffy and from Acting Administrator Chris Rocheleau has never been greater. They are laser focused on ensuring that the U.S. leads in this next really critical age of aerospace.
I love it. How many stages are there? Is stage 4 the last stage?
Stage 5 is the last stage, so we're closing in on finishing stage 4, beginning to make great progress on stage 5.
What is stage 5? What does that mean?
Stage 5 is when the FAA signs off that we have completed every single test. So stage 4 is outlining all the tests that we're going to do, and then we go, once the FAA approves those test plans, we then get to go run the tests, and then we write the test reports, submit the test reports, and then when the FAA signs off on those test reports, we get points. The FAA gets points on stage 5. So when we submit the test report, we get points, and when the FAA signs off on those test reports, they get points.
So is the product effectively frozen now? You've iterated a bunch. It's really great. You're not changing it anymore. It's ready to go. You're confident in it. What is the kind of fun engineering stuff you get to do then? Is the scale stuff the hard part? Like what else do you get to be working on?
So we're working on building out the Vertiport network. So as you look at, one is ramping manufacturing, and 2 is building out the Vertiport network. So the thing that's exciting about these kinds of aircraft is compared to ground-based transportation, whether that's rail or cars on the road, those are linear. And so if you want to get more capacity, you need more lanes. With this, you build a new vertiport and you can go to any other vertiport on the network. Yep. So it's like an information network or anything. It scales like exponentially.
You can go different heights for different lanes.
Exactly.
Yeah. What are the rules? Tell our listeners. I assume it's similar to the airplane rules where you go different heights for different directions. How does it work?
We fit into the airspace just like every other aircraft does, but it's phenomenal that this administration is leaning in and really driving forward on revitalizing the air traffic control and expanding the capacity of our air traffic control system to prepare for this really exciting new future.
And I love this administration is so forward. I think the last one was not too bad in FAA either, actually, despite their other regulatory issues. It seems like everyone's been pretty positive in general, or were there unreasonable things you had to deal with?
So there was a bit of a curveball that we got thrown when they changed the regulatory framework under which we were going to get.
What year was this?
Around 2022.
Previous administration had some things they changed to slow things down a bit.
Yeah, we had our path agreed to with the FAA, and that made it so that we needed to go back and relook at a number of pieces. And the good news is that all of that work is behind us. We've done that work, but it definitely, we would have gotten to the finish line a lot faster if that curveball hadn't come along.
Well, we've just recently heard exciting news about Toyota increasing their partnership with you, helping you scale. There's a great interest in this area. I think you're going to be launching in Dubai with Joby in the coming year. And I hear you're also recently announced a big partnership with ALJ, a big Saudi group. It's a $1 billion partnership?
That's right. So this dates back to when ALJ invested in our Series C, and ALJ has been a Toyota partner, one of Toyota's most important distributors for 60 or 70 years. So they're very close on that side. ALJ is also one of a really fantastic technology investor, one of the earliest investors into Rivian. And so having them as a partner, they've been working alongside us as we've been building out the Saudi market over the past few years. And we're now formalizing that partnership where we'll be working on the sales and distribution of aircraft in the kingdom, and also the support of those aircraft. And so there's a ton of different opportunities across Saudi for air taxi operations. Saudi is really leaning in. They're growing at a very rapid rate. Riyadh, the capital city, is seeing huge population growth, and therefore traffic is becoming very, very challenging. There's also incredible opportunities on the tourism side. ALJ is really our dream partner as we look to explore the opportunities in Saudi, and couldn't be more pleased with this initial tranche of $1 billion for the commercialization in Saudi.
I love that you got there before China, and it's a very forward-looking kingdom, so that's going to be exciting to see what they do. I want to talk about, there's been like a little bit of interesting things in the background going on where I think a lot of people are jealous of Joby because you guys are the leader. When you're the leader, you get attacked. You get a lot of crap. And so I think you guys, like you said, you're first through, you're going to be the first to deploy. So other companies have been trying to throw shade at you. And so this has been interesting for me because I think I helped lead the first round, when you guys raised institutional capital with a couple other friends. And then later on, there were other funds. One fund that put $1 billion in is my friend Michael Thompson, who I feel like I'm friends with both sides, but I'm kind of on the moderate right. I'm on the right. And Michael is on the right, and his partner Reid Hoffman's on the left. And they put a ton of money in. And I think some people who are really jealous of you are trying to attack you because Reid's on the left. They're trying to say, it's Reid Hoffman, we should stop them with the administration, which to me is like ridiculous. Like there's a lot of people behind your company on all sides. It seems like it shouldn't be political to try to like have like safe, like convenient, affordable ways to get around better, which we could talk about why it's good for society. But they've been going at you, and they've been trying to like write stories and get journalists to come after you to try to turn the administration against you. Like what's going on with this? Is it typical jealousy and sour grapes? Like is this something you expected?
Certainly didn't expect it, and yes, I think that's true. I mean, we're a great American and success story. Designed, built, tested this. We've created an industry. We are the model for this new industry around the world, and I think. When we're creating a new industry, like everyone in it should be paddling together and trying to create this, exciting new mode of transportation and, lifting everyone up rather than trying to undermine.
Yeah, well, I think when you're losing a battle which other companies are to you, then there's other things. It's interesting. I've always worked with people on all sides. I feel like part of what's great about America, it's a pluralistic society. So I have a lot of investors who agree with me on a lot of things, and I have some investors who disagree with me on things. I think for a while we had people from Soros, we had people from Coke, we had people and I think that's what's cool about America is we don't have to agree on everything politically. We probably don't, but let's like work together to get great things done and to help everyone. And it was frustrating me. I heard that these people are trying to play out these attack stories, I guess, hopefully you don't have to pay too much attention to it.
We are laser focused on delivering on the mission. This is so exciting, and the progress we're seeing is accelerating. As I mentioned on the both the Joby side and the FAA side, we've got a record number of aircraft flying. Now more than 5 aircraft. We have flying thousands of flights. A larger and larger percentage of the flights have got pilots on board now. We're preparing for FAA TIA, which is where FAA pilots get in the aircraft and they begin flying.
It's a cool job to be the test pilots for these things, huh?
Absolutely. And another phenomenal thing is because these aircraft are fly-by-wire, it means that we can fly them with a pilot in seat or fly them with a pilot on the ground, and it's completely transparent. They fly it exactly the same way with exactly the same controls.
Or a computer could fly it. In theory, obviously, once you have thousands of these, it's probably very safe to do that. That's against the law right now, I guess, right?
No, it's just that we're in parallel with our piloted certification, we are developing the technology stack and preparing for autonomous operations. And
so the regulations may support that if you show that it's safe already.
Absolutely. And there's phenomenal progress that's being made by the FAA and the DOT on putting the framework in place for that really exciting future and for all sorts of new next generation aviation technologies. So the tailwinds, and it's really vitally important that they do that. So that America can continue to lead in this next stage of aviation. You see countries like China where the CAAC, which is the Chinese equivalent of the FAA, is very forward-leaning, and they're already have companies in this sector that are certified. And then you have the Chinese government, which is buying hundreds of these kinds of aircraft, placing orders for hundreds of these kinds of aircraft to drive what they call the low altitude economy. Mm-hmm. And so aviation has been one of the US's most important exports historically, and it's vitally important that the US continues to lead the way in this next stage of aviation.
There's going to be thousands and tens of thousands of jobs if we get it right. Obviously, you have to hire here. So tell me, I think I've seen China has these drones that are maybe competing with you, but a lot of them don't have wings, which seems way more dangerous. So is there a similar design to Joby? It's also competing? Or are they different designs? What does it look like?
Well, they say that imitation is the finest form of flattery. There's now dozens of companies that are building aircraft that look almost identical to ours. And so it is, the amount of competition is going to be very intense.
It's going to be intense from China. They're very good at copying things, but that's interesting. So you got to go fast. And this is a big problem in biology, is that we'll start something here that's based on a new breakthrough, a really important new target. And because the FDA is so slow, because it takes you a decade, and China only takes 4 or 5 years, they'll literally start something a few years after taking all of your insights, going really slightly differently to get around the patent, and they'll sell it back to our pharma companies before we finish. So it's like they're very good at this. So I guess I wouldn't be surprised if they're trying to do something here like this too.
And that's why these new regulations and the work that the FAA is doing to make it to transition the way that aircraft certification is done for really small aircraft. So for the air taxi that we're building, it makes sense to use exactly the path that we've gone down. But for smaller aircraft, it can be good to have a faster and more nimble process. And so
you're trying to create that.
The FAA has built the rule set for that, and the DOT is making great progress on finalizing it. So that lean in and that ensuring that American innovation can thrive is so vitally important.
So let's talk a little bit about how this changes society if this works. For American society, it seems to me that there's like places that you could have lived, but there's just no connections to them that are too expensive. So all of a sudden there's like land that might be like 80 miles outside of a city that all of a sudden is a really attractive community to live in. And I'm curious how you think about it. In my view, you might have like this beautiful village, whatever you're all living in, that was basically cost nothing before. All of a sudden it's really nice. In my view, you could build like one really big building and put it on top. Because you tell me, but even if these are quieter, you'd still be even quieter if it lands high up. How do you think about this, and how's it going to work?
Yeah, I think that's exactly right. And you look at real estate, it's a $300 trillion or $400 trillion global asset class. It's I think probably the world's biggest asset class. Yeah. And real estate has all through history been all about location, location, location. Now you can take a piece of real estate, beautiful spot, but that's inconvenient to get to, and you now have access to this new mode of transportation. So lots of people around the world spend more than an hour a day commuting. And what if you could turn that hour into 10 minutes? What if you could take the people who spend 2 hours a day commuting and turn it into 15 minutes? And that is the promise and the productivity. I think that companies around the world are competing for talent, and being able to get the very best people and to allow them to be in the office and all work together is vitally important.
Yeah, being in person turns out is really, really useful. Is it, so it's 100 times quieter, 50 times quieter? How do you measure that? What's the actual number?
Yeah, it's about 100 times quieter than a helicopter, and that's in hover. And then in overflight, it's nearly silent. So it's
like,
really
like a quiet plane because it's electric, I guess.
Exactly. So it's really fun because we have folks come down into the flight test facility, and a bunch of people will be standing around, and you go shh, because in order to be able to hear it when it flies over, it's just this shh.
Oh, that's cool. Which I appreciate, by the way, because they're going to be around everywhere. We don't want to noise pollute the whole friggin' city.
Yeah, and that's when it's flying over at less than 1,000 feet up.
So it's even higher. You're not even going to hear it.
It's like completely silent. So
I love it.
Somebody was like, "Wow, that sounds like a jet when it's up at 10,000. The jet's up at 10,000 feet, and yet this is just flying right overhead."
And is it the case then you probably want to, let's just say I build out near I've been going to a bunch of land in Texas. If I build it higher, we not even hear it barely taking off, or how do you think about that?
Exactly.
We're here in Woodside today because you're based nearby. Should we have one big building in Woodside we can all land on? Is that a thing we could convince the neighborhood to do, and then it'd be convenient in a few years?
I mean, the aircraft we have today, it makes sense to have a few different takeoff and landing locations in Woodside. Yep. But where I want this technology to get to is where you can land, in a place like Woodside, you can land at home because it's so quiet that the neighbors don't even hear it.
It's actually going to get even quieter. How do you do that?
So we've been working on acoustics and really focused on acoustics since I founded the company 15 years ago. And our research team is very laser focused on continually progressing quieter and quieter aircraft.
I guess we shouldn't tell the Chinese listening your secrets, huh? It's something, I remember you explained it to me once also. There's lots of rotors, and I think it's correlated with the fifth degree of the rotor. Can you explain this part again?
Yeah. So it goes as the tip speed to a high order.
So some high orders like that. Yeah.
And so you want to slow the propellers down as much as you can. It's also about the design of the airfoil on the propeller blade. We also do this interesting thing where we vary the spacing of the propeller blades. So instead of having a consistent harmonic, spreads them out, and it spreads the noise out, and so that gives it that shh sound instead of the.
So it's quieter versus a pulsing sound. That's
Exactly.
Interesting. What are some of the other engineering challenges you can tell us, actually? Because you've obviously, you know everything about how to build these things. What were some of the hard ones in the past you had to figure out?
So we've chosen as a company to be incredibly vertically integrated. So we want to make the best flight computers. We want to make the best air data computers. We want to make the best motors. We want to make the best battery packs. We want to make the best actuators. And that, when you sum that up, it means that we can build the most performant aircraft. We've taken an approach very similar to what you've seen, with a company like SpaceX, where by owning the entire stack, you're able to build something that's dramatically more performant. That means that we can move people from A to B faster, more affordably, and safer, and more quietly.
So is this like a very advanced Model T, and in 10 years it's going to be like even way better? Is that where the space is going? Just what's it going to mean for the average person in the middle class if you want to live, let's say in 10 years from now, you're 100 miles outside of a city, and you're just going to have a commute where you're probably not going to own it, right? It's probably going to come pick you up because it's much easier, and you'll be in your carpool maybe. And how much better does this get? What's the experience?
I think you're going to see both of those things. You're going to continue to see the shared ownership model blossom. So we're very focused on building out air taxi services in cities around the world, and we think
it's like Uber. It's an alternative to Uber. Yeah.
Well, we have an incredible partnership with Uber. So we have the partnership where they're a demand funnel, and where when you pull up the Uber app and you say you want to go to, you're in New York, you want to go to JFK, that it'll seamlessly stitch an Uber trip to the Vertiport and a Joby flight to the terminal all together in a seamless package. Also, we acquired the Uber Elevate team from Uber, and that is the foundation of all of the servers and the algorithms that run on the back end based on Uber's best-in-class architecture, and then also the app. And then we've continued to develop that. We've got an amazing team. So very grateful for the partnership and very grateful for the technology stack.
When do I get to use the app?
So we're going to be rolling this out sequentially as we roll out in cities, both here in the U.S. and internationally. And we're so excited to welcome you on board.
So there's next year, there's a good chance I get to use the app somewhere.
Yes.
Okay, that's really cool. And then, I'm curious. So SpaceX and Palantir famously kind of broke into the government cartel of it's basically impossible to work with it, and it took us many years. We kind of pushed through, and we laid some tracks, and then Andrew laid more tracks, and there's a lot of stuff happening there. Is this something like this where you guys have maybe, by becoming this first big winner like a Palantir or SpaceX, maybe have made it easier for others to innovate along these lines, and there's going to be more types of things going on like this?
Absolutely. So we started working with the DoD back in 2016 with DIU, and that laid this incredible foundation for us with the DoD, and it was that expanded with the work with AFWorks. DIU has been a spectacular partner for us for many years. And we think that both the existing aircraft and then hybridized versions of it are going to be incredibly valuable. Also, the hydrogen electric technologies that we're pioneering are going to be game changers for a bunch of different dimensions of work on both the commercial side and also on the DoD side. So we do think that the pioneering pieces we're working on, also the pioneering pieces we're working on the autonomy side. Mm-hmm. So we acquired a team called X-Wing, which is one of the leaders in aircraft autonomy, and they're doing fantastic work on autonomous logistics and other autonomy applications for the DoD.
And Rebel aircraft, apparently.
Exactly.
X-Wing, that's a great name. What would you say to people who are looking at problems this big? I mean, even when I invested with my team in this about a decade ago, even the people talking about flying cars wouldn't give you money, and people thought I was pretty crazy. And then you were doing this for even years before that. What inspired you to take on such a hard and tractable problem? And how did you know you were going to be able to be successful? It seems impossible to an outsider. What got you motivated to keep going and to make this work?
I think that for me, the only problems that are worth working on are the ones that are going to have massive societal level implications. I've always cared about transportation since I was a little kid. I dreamed of building vertical takeoff and landing aircraft. And so, having started and built a number of successful companies before, I felt like this was the best way that I could give back. Life is short, and so we might as well spend it solving really big and important problems. I think this is a really big and important problem, and having partners like you and everyone else that has had the fortitude to really envision this new industry and then step by step build it. That's been an incredible journey. I'm so grateful.
Were there any really strong negative people early on who are now admitted they were wrong or something? Or do you remember any doubters who got you down early on? I'm curious. Is that something, or do you just ignore that and you put it out of your mind?
I usually have confidence that over time I'm gonna get everybody else on board. But I had some Wall Street friends that I remember telling about this back in 2008, and they were like, "Are you serious?" And then they're at each step along the way they're like, "Wow, you're actually doing it! Like this is you're gonna change the world." And so it's been really, really fun.
When did it become clear it was working?
I think it's been progressive. We're just progressively a little closer. But I think when we flew the full scale in 2017, and we were able to show both to ourselves and everyone else that we could build an aircraft that was incredibly quiet, that had redundancy, that had unprecedented performance. That was really, really exciting.
If people want to partner, there must be I have a bunch of listeners who are real estate billionaires who they're this is super cool. What should they do to be reaching out and partnering with you? Are there people trying to get communities ready or land ready? I mean, it seems like there's all these opportunities.
Massive opportunities. And, as we look at building out new developments outside of cities, as we look at building out, brand new cities, this is such an incredibly synergistic opportunity. And then even people who are building new developments in a city, this is so exciting. We would love to partner with all of them. And it's just the opportunities and the synergies here are spectacular.
If Joby's worth hundreds of billions of dollars, are you going to use some of that money to build new cities or build new things?
Absolutely. I think where we are today is the most exciting time in the 40 years that I've been working on technology. The rate of progress and the opportunities to transform the future and the speed at which we can transform the future has never been greater. When you look at the ways that we're able to apply AI to the problems in the physical world is just so exciting. And the acceleration of knowledge and the acceleration of productivity, I can't wait to see what we're going to create at Joby and what the world is going to create over the coming years as we apply all of these technologies to accelerating aviation and societal transformation more broadly.
As it goes officially commercial and people are paying for it, who's going to take the first commercial ride?
Well, we've got a long line, but you'll be right at the front.
All right. Thanks so much, Joe Ben.
Thank you. Wonderful to be with you.